All right, let's talk about something we've all dealt with. You know the moment you click a button in an app and then nothing. Everything just freezes up. You get that dreaded spinning wheel of death and you're just stuck, waiting. Well, today we are going to pull back the curtain and unlock the secret to fixing that. We're going to dive into two really powerful patterns that make software blazing fast and super responsive, all by letting it do more than one thing at a time.
So, let's just start with the big question right off the bat. Why does this even happen? Why do our favorite apps sometimes just lock up, leaving us staring at a totally frozen screen? It's this universal headache, but the reason it happens is actually surprisingly simple.
And yeah, this is pretty much the culprit. Most of the time, the app is trying to do everything in a single, straight line, one task right after the other. So if one of those tasks is a really big one, like downloading a huge file or running a super complex calculation, everything else gets stuck in traffic right behind it. And that includes the user interface, the very part of the app you're trying to use. It's just blocked.
And that right there brings us to the core challenge we're going to tackle today, what I call the unresponsive app problem. It's a really fundamental issue in how we build software, but thankfully, the solution is pretty elegant.
I mean, what if, instead of forcing everything to wait in that single file line, we could get our software to, walk and chew gum at the same time? This whole idea of doing multiple things simultaneously, that's called parallelism. And it is the absolute key to building apps that feel snappy, alive, and just responsive.
Okay, so let's meet our first pattern for making this happen, the background worker. Honestly, the best way to get this is to picture yourself as a super busy executive. You wouldn't stop everything you're doing, all your important work, just to go run to the copy machine, right? No way. You'd hand that job off to your helpful assistant.
And that is precisely what a background worker does for your app. It's a design pattern that takes one of those big, long-running jobs and just offloads it to a separate background thread. You can think of a thread as just an independent little path of instructions your computer can follow. So while that big job is getting done in the background, your main application, the user interface, is totally free for you to keep using. No freezing.
So how does this assistant actually work in practice? Well, first, the main app, our executive, gives the worker a specific task request. Then, and this is the crucial part, while the worker is off doing its thing, the app stays completely responsive. You can keep clicking buttons, typing, whatever you want. Then, once the worker is all finished, it just brings the completed result back to the main app. See? Simple and so effective. Now, this is where it gets kind of cool. That task request isn't just some vague order. It's a really well-structured package. It's got a unique ID, which is basically like a tracking ticket, so you never get your jobs mixed up. It's got the data, which are the actual instructions for what to do. It has a spot for the result, where the answer will go, and it even has something called task state, which is like the assistant's own private little notebook to jot down notes on the job's progress.
Okay, now listen up, because this is the golden rule, and it is absolutely non-negotiable when you're using this pattern. The background worker, our assistant, is strictly forbidden from touching or changing the user interface directly. This strict separation is what keeps the whole app from descending into chaos. Think about it. The assistant brings the finished report back to the boss. They don't start rearranging the furniture on the boss's desk themselves.
Okay, so the background worker is perfect for one big, heavy task. But what if you have a continuous stream of things that all need to go through the same series of steps? For that kind of problem, we need a totally different tool. So let's move on to our second pattern, the data pipeline. Or, as I love to call it, the data assembly line.
It works just like it sounds. Like a real factory assembly line. The pipeline pattern breaks a big, complex process down into a whole series of smaller, specialized stages. Your data flows into the beginning of the line, each stage does its one specific job, and then it just passes its work on to the very next stage.
Let's make this real with a great example. Imagine you're building an app that analyzes a bunch of text files. Well, stage 1, the folder scanner, just finds all the files you need to look at. Stage 2, the file reader, reads what's inside them. Stage 3, the stat collector, counts up all the words and lines for each file. And the final stage, the stat aggregator, adds up all those counts to give you a grand total. Each stage is a total specialist, laser-focused on just one part of the job.
And this is where the magic really kicks in. Let's say one of your stages is a bottleneck, like maybe reading files from a slow hard drive is taking forever. Well, with a pipeline, you can just run multiple copies of that slow stage in parallel. So on a modern computer with an 8-core CPU, you could have 8 file reader workers all running at the exact same time. This can just dramatically speed up the entire assembly line. It's incredible.
So you might be wondering, how do all these different stages pass work to each other without just making a huge mess? They use what you can think of as conveyor belts. In the tech world, we call them channels or queues. But basically, they are just little holding areas that safely pass the data from one worker to the next.
And these conveyor belts, they're smart. If there's open space on the belt, the stage before it just keeps on adding new work, and everything flows smoothly. But if the belt gets full, the stage before it automatically hits pause. It just waits for some space to clear up before it adds anything else. This brilliant little mechanism prevents any data from ever getting lost and makes the whole system self-regulating. It's a beautiful, elegant way to manage the flow of work.
So now we have 2 really powerful patterns in our toolkit, the personal assistant and the assembly line. And the real key to genius-level software design is knowing which tool to pull out for which job. This slide here just breaks it down perfectly. You want to use the background worker, your assistant, when you've got one big chunky task that you need to get done without freezing the whole app. And you want to use the data pipeline, your assembly line, when you have a stream of items that all need to go through the same multi-step process. One is all about offloading a single job, the other is all about managing a continuous flow. So at the end of the day, why does any of this really matter? Well, it's because modern computers are literally built for this. They have multiple cores, sometimes dozens of them, all capable of working at the same time. Not using these patterns is like owning a Ferrari and never taking it out of first gear. You're just leaving so much power on the table. So if you're going to walk away with anything from our time together, here's what I want you to remember. First, these patterns are how we build fast, fluid software that actually respects the user's time. Second, they teach us to break down huge, overwhelming problems into small, manageable pieces. Third, learning to think in terms of flows and delegation is just key to writing modern code. And finally, it's all about using your computer's full, incredible processing power. And that kind of leaves us with one last thing to think about. You know, we spend so much of our lives trying to do one thing perfectly before we move on to the next. But our computers are this amazing reminder that sometimes the most powerful way to work is by doing many things at once. If our machines are designed to think in parallel, well, maybe we should be too.